can successfully connect to.
Yeah, sorry for the... Yeah, so let's wait for some people. Yeah, so sorry for the last stream. I had a urgent meeting, so I had to leave for that. So let's continue reacting. So we were, I think, somewhere here.
Scale right in
Let me
industrial
also get my
use,
drawing pad.
but that also there is a demand in industry for the same language from other developers, and how the language was started. So idea was to create a modern, concise language in which you can really write a lot of code and navigate easy around, to remove all the boilerplate from the code, and so that you can focus on the essence of the code. So I'm getting there, good to go. We also have Mike from Codeforces here, so he'll start the contest for us. Yeah, please refresh the page.
Oh, so Mike was also there. This is from ICPC World Finance, right?
Let's see. Yeah, we
Uh,
see.
let's go to the drawing pad.
So we'll rewind start. Did you win?
Yeah.
Some experience with like contest. Usually 100 point. You have this candidate they choose.
So the problem was the first one was easy. So I think they had three candidates, A, B, and C, and they had some number of votes. Let's say this has five, this has let's say eight, and this has six. And the number of votes that this candidate requires is how much? It is just B minus A plus one maximum of zero, and then how much? This is just C minus A plus one, right? So we have three variables, b minus a plus 1, c minus a plus 1, 0. This is for needed by a. And you can do the same thing for b and same thing for c. So the problem was easy enough. Let's see where did...
Yeah, each of
so he did b plus c plus 1 minus a. So why did he do that? So we have 6 plus 5. Sorry, 6 plus 8 plus 1 minus a. That makes no sense, right? I think he misread the problem. And I'm audible, right? Yeah, I think I'm audible. So I think he misread the problem. Am I audible? Yeah, so I think Ecnerwala misread the problem, because if we do that, the formula that he applied here, we'll get 6 plus 8 minus 5. So this is 14 plus 15 minus 5. This is, I think, 10. So I think this is not correct, right? So I think he misread the problem.
them
Let's
choose to
see
copy
what
and paste
Errichto did.
3 times the code, but you can also
So he got a wrong answer, obviously, because the
locally.
answer was not correct. Let's see what Errichto did. If they show his code. Yeah, and I think now he is looking at his code.
Yeah, it's not this simple.
Yeah,
I can.
he misread the problem. Yeah,
I mean, the
yeah. So like if you look at Errichto, he's doing the right thing. A b minus a plus one. Yeah, so he's doing the right thing. So he's applying this one formula. Right, so he's doing b minus a. So he combined these two things. We have formula as max of b minus a plus 1, c minus a plus 1, comma 0. So he combined these two and he wrote it as maximum of bc, right? So he combined these two terms. So he wrote like this. Yeah, so I think a bad start for Lewis.
I wonder if should I hint them what's the bug is. Let me see what.
And Errichto is not using, right? So if you see here, Errichto is not using a formatting. So like he's like just printing X then Y then Z. A better way to do this should have been print. Then I think in Python it is just like this, right? And I think it's the same for Kotlin as well. So I think this should have been better to print. Right? This is far simpler. You can format the strings. But I think it's his first time using Kotlin, so I don't think he knows that much about it. We see, yeah, so you have to use a dollar sign as well. So you can use print dollar of x, dollar of y, then dollar of z instead of like writing these 6 lines, right? This would have been far simpler and faster. I
Yeah,
think
it's not this
it's
simple. I can.
yeah.
I mean, the
Also one more thing, I think they will have to write their templates from scratch, right? So I think that's also not good for them because if you have to write a segment tree from scratch in Kotlin, I think that will be pretty hard for either of these guys. Still, and I think Errichto usually writes his templates from scratch. So I think it will be easier for Errichto than Ecnerwala because Ecnerwala uses lots of templates.
I
So yeah,
wonder if should I hint them what's the bug is. Let me see what.
yeah. So Errichto got the correct answer. He's going to submit it.
Oh yeah, that looks much better. Camille's code looks much closer to what it needs to be.
Yeah, he's getting accepted. We have no concurrent viewers. That's really
Oh
sad.
yeah, Camille's accepted. Yeah. Oh. It's way easier, so then the way to solve this problem is way easier if you just sort 3 numbers and take the largest and second largest and look at them in a loop. That's the code is way shorter and easier to understand. And let me introduce you this second problem that Camille is
So let's go to this one. It is given in a position in one move. You can select an integer and move it. Once selects one position the number and removes the digital bit within the operation cannot be found if only one remains. The remaining number contains leading zeros. Removed if one removes from the number the trade, one removes the first digit. What is the minimum number of steps to get a number such that it is divisible by 27 positive? It is granted that for each n occurring in the input, the answer exists. It is granted that the number n has no leading zeros. The number n has no leading zeros. So I think so like if you try to see the pattern in this one, we have been given some number. Let's say the number is, let's say D. It has D1, D2, D3, D4, so on up to Dn. So let's say it has 18 digits, right? You have to make this a multiple of 25. And if you look at multiples of 25, we have 25, we have 50, we have 75, we have 100, 125, 150, 175, 200. So if you see the last two digits, we have only four possible sets, right? There are only four possible sets. Either it can be 25, either it can be 75, either it can be 50, or either it can be 00. So we can just, I think, iterate over all the possible combinations and find the minimum number of steps that are required to make any of these combinations. I think that should be the answer, according to me. Let's look what they do.
to solve. So you have a number with many digits. In one operation, you can remove a digit, any digit. If you remove the first digit zeros from the beginning are dropped, and your goal is to make the number divisible by 25 by removing the fewest possible number of digits. That's the goal. Andrew, just write the loop.
Andrew, like, West time or problem में Errichto has a lead for now, I think. Right, yeah, so he's doing the same thing. I think he's defining four sets of variables. 25. Oh, I think I know that guy. The third one. Who is he?
Okay, so
I'm creating a function.
Camille is okay. Sending the
Let's skip forward a bit.
string. Okay.
Case 1 ends with 5.
Square bracket. It's not Rust. It's not Rust. You need to do square brackets on the ifs.
Too much Python.
Yeah, too much. Right? Yeah. I think they would have solved this problem in like 2 minutes if it was C++, but they're struggling because it's Kotlin. Errichto always writes like very pretty code. Where past is equal to 100.
Okay.
Let's try to look at his code, what he's doing. Let's try to screenshot this. See what he's doing. So answer is equal to minimum of answer, goal 25, 50, 75, 0, 0. Yeah, so he's doing the same thing. He's just checking for every last bits, put the answers.
Yeah, we see Camille almost there for his 4 cases. Let's see if it actually works. Now, now he's going to test it locally.
Oh, he's getting some errors.
Nope, doesn't compile. Because, yeah, return type.
Return.
Comma. Not comma, sorry, the semicolon. Just like semicolon, yeah.
And this dude is helping them, bro. Kind of cheating, you can say.
Nope.
Two, 5, 3.
No, that's an important tweak, yeah.
Yeah.
Yeah, you don't need to count the twos you leave at the end.
I think Errichto is gonna win this one. He has a pretty nice lead. Let's see. I think Ecnerwala is more fluent in Kotlin.
I think.
So I think yeah, Ecnerwala is Lawrence is more fluent in Kotlin. So I think he will have a better time when like implementing harder problems. Camille has some kind of a point lead, so he only needs to solve, I think, the 3-node problem and he wins. So let's see. It's important that Lawrence solves the next one faster than Camille, otherwise he's lost. Yeah, I
Good.
solved it. Yeah. Damn.
So let me introduce the next problem, the problem C on.
So let's see. Problem C is. So in problem C, there are one cat, k mice, and one hole on a coordinate line. The cat is located at point 0, the hole is located at point 10. All mice are located between the cat and the hole. The ith mouse is located at point 0, xi from 0 up to n. At each point, many mice can be located. In 1 second, the following happens. First, exactly one mouse moves to right by one. If the mouse reaches the hole, it hides. Mouse will not anymore move to any point, will not be eaten by the cat. Then after that, the mouse has made the cat moves to the right by one. If at the new cat position some mice are located, the cat eats them. The actions are performed until any mouse hasn't been hidden or isn't eaten. In other words, first we hidden mouse. Yeah, so I think this is easy as well. So we have a cat that is at point 0. There is a hole at point 10, and there are some mice. At every second, one mice can move. Only one mice, exactly one mice can move to the right by one, and then after that, cat will move to the right by one. So uh, that's it, right? Yeah. So if a mice reaches the hole, that is, if it reaches point 10, then he is saved. So you have to find the number of mice that can be saved, right? So I think that is also easy. So yeah, like you can just keep going to the right side, and every time whichever mice is closest to the hole, I think you can do greedy on this. Greedily, you can always pick closest mouse. Always pick the closest mouse to the hole and try to save it. Now, why am I saying this greedy approach? Because I just thought of a test case, right? So let's say you have 3 mice and they are something like this. So this is at distance 3, this is at distance 6. Let's say your cat is here. Let's say your cat is exactly here.
That Camille is reading. So you have a line, and a line is the length n. You have a cat sitting on one
Yeah,
side,
bro.
and you have a hole on the other side, and you have n mice.
I am currently working
And
at Equinix, and I also have upcoming intern. So like, if you want to see my LinkedIn, I will drop my LinkedIn in the comments. My internet is really bad. Sorry for that.
uh, uh, cat and mice alternate their turns. So cat moves to the right every turn, and one turn each. One mice can move to the right. Just one mice per turn. If mice reaches the hole at the end of the line, then it disappears there. And once cat reaches a mice, it eats a mice if the mice has not got into the hole. So your goal is to move mice in such a way as to save the most number of mice from being eaten by the cat. And meanwhile, yes, Andrew is also on top of this problem. So we have both of them trying to save most mice. So let's see. Let's see how it goes. Yes, and K, and yes, the array of mice. Yes, that's the input. No, it's not Python. Yeah, that's.
Oh, very like Lars is struggling. I think he's in some kind of pressure. So you can follow me on LinkedIn if you guys want to. I will leave a link. Oh, no. Yeah. So let's continue with
No,
the
it's
video.
not. Not no range. Yeah. Okay. Let's see what they come up with. So, Andrew's submitting the second one.
Exactly one mouse moves to the right by one, if mouse reaches the hole it hides, can moves to the right by one.
And also reading the reading statement for saving wise. Let's see Camille's coding.
Okay, so
Oh, yeah. So I think you can improve on the complexity on this one. What you can do is like move this mice. So let's say your cat is at, let's say, 0, and let's say your hole is there. Let's say the closest mouse. The closest mouse is at, let's say, x points, or so you can say x units before the hole. You can just remove the last element, right? Remove this and just add the cat by x units. I think that will work all this, right? Then all the mice that were before this will be eaten. So that also works. So you can iterate from the end. You can sort the array, sort array in reverse by mouse coordinates, and then initially your cat, you can say your cat position is equal to 0. Then let's say your current mouse is equal to, let's say, array of 0, right? Because you are sorted in reverse order. So if your current mouse is equal to array of 0, or you can say array of I, where I goes from 0 up to n minus 1. So your current mouse is equal to array of I, and if array of I is less than or equal to your cat pose, then you can say break, because all the mouse have been eaten. Otherwise, you can say cat pause plus equal to n minus array of I, right? Because this mouse will be saved. This mouse will reach point n, and in that time, cat will also move forward some points. And you can say save plus plus, because this mouse will reach hole, so this mouse will be saved. Yeah, so I think that also works.
select a mouse. Holes located at n, I crosses.
I think he is doing the same thing, right? Yeah, he sorted, or did he
What is
not?
that? That's some kind of a greedy. Oh, good. We have. I hereby applause that Andrew has solved B. So far so good. They're going really close.
Thanks, bro.
Really, really close. Let's see how it goes. So they will be solving C, and I really don't know what Camille is thinking about. Let me try to figure out what he's trying to do. Yeah, you can just sort it in Kotlin. Yeah, that's right.
Yeah,
That's how it sorts.
sorting in reverse order also works, or you can sort it in like straight order. That also.
Never applies to enrich the whole without being eaten.
Okay, he tries to figure out some kind of greedy algorithm here. Let's see if he's successful in this.
No, he is using assert and
Meanwhile,
was
Andrew's starting to. Okay, also.
yeah. So he's also sorting, right? Or is he not?
No, just.
You just need to get to here before the cat gets to the hole. Right.
Autocorrection. Okay.
Doesn't really matter. Cat.
Camille's still trying to debug it.
Please show us Errichto's code so I can look at it and
And steps.
see what is missing. I think I should be able to figure out the bug in Errichto's code
Okay, let's
at
give
this point.
them some time. I wonder if it's going to work.
Yes, let's see his code, what he's doing wrong. So he's doing read ln. Yeah, so he's sorting the array. And sum is equal to 0, answer is equal to 0. So count I in 1 less than equal to n, where I is equal to n minus count. Sum plus equal to count into L minus AI. What does that mean? If sum is less than L, answer is equal to count.
I won't spoil the way I solved this problem, but I took completely different approach.
So I think there are how many problems? 100, 200, 300, 400, 500, 600. So Errichto has currently solved, I think, all three of these. So he is currently at 600. So now Lawrence has to solve, I think, two of these three problems to win.
So let's see if they can debug theirs.
Let's see if Errichto's gets accepted or not. I was not able to understand what he was doing in his
No,
problem.
it doesn't work.
Oh, it got accepted, yeah. Oh, nice. So let's read the next problem. What have we been given here? So a tree is, also we know what a tree is. A tree is an undirected graph which cycles the problem is one of the true split of trees. What is that? The gardener vitally grew a tree from n vertices. He decided to trim the tree. To this, he performs a number of operations. In one operation, he removes all leaves of the tree. For example, consider the figure of in the tree one operation. I think I have solved this one.
Successful.
Practice, bro, here. Practice is the only thing that helps. Like if you know all the concepts and if you are not able to apply them in the contest, try to give virtual contests.
So while I was watching Andrews, Camille's managed to fix it. So let's see this. This one is straightforward. So you get a tree here, and which is given by the set of edges.
I think you have to find the minimum number of steps that are required to make to require to like trim the tree, right?
And your task is to prune the leaves from the tree k times, where k is given in the input. And this will require using some
Graph
data structures to
algorithm.
𝐞𝐽, etc. So let's see how much Kotlin help they will need to get the data structures they need to store all of it. So
Yeah,
in simple,
so
it's just
yeah, so like Lawrence is doing something like what I was doing. So he's doing the same thing. He's starting from the end, I think. Yeah. So he's starting from the so he reverse sorted array and he's starting from the end and he's just pushing mice. Yeah. So he's doing something like what I was saying.
the number of vertices in the tree and k, the number of times you have to trim the leaves from the tree. And then there is the list of edges. Be careful, the input is tricky here. It also has an empty line before each input.
Features and contains elements. The number of vertices that remain in the tree after applying k operations. Okay. So I think you can just do we can run a BFS, a multi-source BFS. I think that should work, right? So I think a multi, so like if we consider all the leaves as nodes, then a multi-source BFS should work. So we can like assume all the leaves are roots and then do a multi-source BFS, and we can keep track of level of every node. And if level of a node is greater than or equal to k, or you can say just greater than k. If a level of node need is greater than k, then this node will be saved. That's what I think. Right? I think that should work according to me. Yeah.
Yeah, and it's also multitest.
But Errichto if solves even this one, then like Lawrence still has chance to solve 500, 600. He can still win.
Yeah,
It would have
simple,
been
but
better for
it's
Errichto
great to
to
have
go for this one.
some pre-written code like template. So yeah, you can copy from your template, and then which really saves you time in writing. Yeah, the way you read edges, you just destruct it into ng. Yeah, they're both.
Can I have global variables?
They're both using the same approach to read their inputs so far. Let's see what they do next. Okay, so Eric is also computing degrees. Great.
So they are computing degrees to find leaf nodes, I think.
Okay, he's going to use a queue. That's a way to solve it.
So he's using he's using a multi-source BFS, I think, Lawrence. If degree of I is
Arrays passed by
Yeah,
reference.
if you
yeah,
want to
yeah. So if degree of I is less than equal to one, then Q would push, or you don't have to write if degree is less than equal to one. So let me copy his code and then show you. So he is just doing this, right? He is just iterating. He's just taking the input here. This is just in the input part, and then here he's computing degree of every node, right? And leaf nodes have a degree of 1. So then he's keeping a queue, right? Because in BFS you have to use a queue, right? So he's using a queue, and then he's pushing all the leaf nodes. Leaf nodes have a degree, so you don't have to use a less than equal to, because I think in the problem every leaf node. I think this is for cases when your tree has only one node. Yeah. So I think this will be okay. So if degree of I is less than equal to 1, you do q dot push I. So you are pushing all the leaf nodes to your queue. So basically you are assuming all the leaf nodes are your root nodes, and then you can apply multi-source BFS. I think that's what Lawrence will do after this.
DFS, it won't, I mean, the graph is, I think, too big for like straightforward DFS to work. But like if you want DFS, you just need to write it a slightly trickier way. I suggest you to think twice, if you really need DFS to solve this problem, because you're just pruning the leaves here.
Yeah, so like if you want to lie, so like the host said, you have to write DFS in a trickier way. So I think a trickier way to write DFS would be, but yeah, DFS would be very tricky to apply in this, because you have to, yeah. So I think you can use DFS and assume some kind of heuristic. So I think we can use DFS, but it will be quite heuristic, right? So it will be a heuristic approach. So you can use a DFS and keep a level of every node. You can DFS from every leaf node one at a time. So you take every leaf node and apply a DFS and keep a level of every node. Then take the second leaf node. So let's say you use the first leaf node, then apply the DFS, and then record the level of every node. Then take the second leaf node and again apply the DFS, right? But if at some point, level of level of node in your second DFS is greater than level of node in your first DFS, greater than or equal to, then you can just break here. Then you can just break. I think, and then you can do the same thing for the third DFS. When you use the third leaf, do the DFS again. And if your level of node in third DFS is greater than or equal to level of node in first or second DFS, then you can again break. So I think that is how you can apply DFS, right? The optimal approach would be to apply BFS, but if you do want to apply DFS, I'm already placed, bro, at toast. Yeah. So optimal approach would be to apply BFS, but if you want to apply DFS, you can use a heuristic approach. So I think this is not guaranteed to run in O of n. I think heuristically this will run in O of n, but like there is no fixed time complexity for this. Let's see what they will do. The stream is quite long, I think. How much time is it?
In this problem, you just pruning the leaves k times. So k is given in the
40 minutes.
input. All you just do is efficiently implement the data structure, so so he's storing, which is a good way to approach it. Yeah. Yeah, and you're asked what the number of, the answer to the problem is just the number of edges that remain. So you have to prune them k times and just print the number of edges that remain.
Yeah, so he's not doing BFS, he's just like doing a brute force. So he's not using a BFS here. Like he's just doing a kind of brute force. So what he's doing is he's for every like edge, he's going over the array and just like removing the edges and decreasing the degree. And if this is a new leaf, then he will just push it right here. Oh, my logic will not work. So I think multi-source BFS will not work. This is the wrong approach, I think. Yeah, so Andres isn't doing the right thing. For example, if we have something like this, let's say, and this is a leaf, right? So if I remove this, then this new node is not a leaf. So what you can do is you can keep a queue and take every node and remove the nodes and then like decrease the degree of the adjacent nodes. Yeah, so I think yeah, that is the right thing. And if this new edge, then you can keep a you can keep a separate queue called new. And if this new node, if this new node is a leaf, if is it a leaf, you will push it into the new queue. But in this case, it is not a leaf, so we will not push it here. But if I remove this node, this new node is a this leftover node is a new leaf. So I will push this into the new queue. Similarly, if I remove this node leftover node is a leaf node, so I will push this into the queue, and then apply the same step again. So I think that will work. So you don't even need BFS for this, right? So BFS is not even required for this. And if you do a BFS, you have to like keep the maximum answer. So in this case, in case of DFS, these will be reversed. Less than equal to. Here it will also be less than equal. Yeah. So like I'm not explaining the problems, like I'm just giving what I think when I see a problem. So I'm just giving my point of view. Do not take this as like an explanation. I'm just giving my point of view, how I think about problems when I see them. So you guys can get a kind of hint how to think about problems.
For empty trees, yeah.
So I think Ecnerwala is doing it in a better way. He will pass this one faster.
Its first will work. Cotton's first will work. If it's not empty, the first work. Submission, and let me disappoint you, but we'll wait. Okay. Yeah, I think you'll get a time limit on your submission, and let me disappoint you, but we'll wait.
Exactly 1 hour.
Were these problems easy? Yeah, Rohan, they were I think quite easy. They were like if three problems, so yeah, they were easy. Not that hard.
Exactly 1 H.
I'll see if I can help
Why did Lawrence get a timeout? I think it's
figure out. It's still testing. Yeah, time limit. Yeah.
why did he TLE? I think he was correct. Is this a Java thing?
Yeah. It's easy to fix though. Exactly. That's how we fix it, right? that's 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 a trick in this problem. So because they say to do operation k times, but the number of times to trim can be very large.
Yeah. Okay. Okay. So he like yeah. So like k can be 10 to the power 9, but at maximum you will also only have to trim up to k 10 to the power 5 times. So you also have to keep a counter. So if you have removed all the nodes, then you can just break out.
So you just simulate trimming k times. You'll run out of time in this problem because there are
Yeah.
1,000 tests and actually 10,000, 10 to the 4 test cases, and I think k is up to 10 to the 6. So if you just naively trim k times, you just run out of time. You have to break if the graph is empty in this problem.
Like it's really funny to see like these top LGMs missing these kind of like small things. So like you can see that the on-stage pressure is a thing, right? Because like if Ecnerwala is solving these problems in C++ or like he is solving them in his own house, he will never miss these type of small things, right? But currently he's on the stage, he's feeling the pressure, so you can see he's making some mistakes. So can you tell something about 𝐶𝐞𝐫s? What is 𝐶𝐞𝐫s? I have no idea about that.
Yeah, Camille solves it just by doing repeat, making sure he's not repeating more than the graph size times. Yeah, you need to cast if you're using longs. Kotlin doesn't have implicit cast, so unlike Java or C++, so if you're not even widening and lowering, so if you use int and longs interchangeably, you have to cast them explicitly. And somebody asked in code forces, like, why would you even use a for sports programming language that does range checking by default?
Oh, Ecnerwala's first language was Java, though. Okay. Then it's just the pressure, I think. Like, is the syntax quite same for Java and Kotlin? I think there is some kind of difference. So, and you can like see the difference between Ecnerwala and Errichto. I think Errichto knows the answer to this, but he is having struggle to implement it. Ecnerwala knew the solution and he was able to implement it much faster. So like it shows. I think Errichto would have beaten him if it was in C++ or like if Errichto had a better experience using Kotlin.
I mean,
Errichto is just a good implementation, right? That's like what I was saying previously. So like Errichto can solve like Errichto has better experience handling pressure. So he was able to solve problems faster, but he has less experience in solving using Kotlin. So Ecnerwala has like a heads up when trying to implement harder problems because harder problems require more implementation. So obviously Ecnerwala has the upper hand in harder problems, right? So if you see Errichto is also doing the same thing. He's also keeping degrees and doing the same thing. But the issue is like his implementation is really slow in Kotlin. He's struggling to implement it. You can see the errors, yeah.
you're getting in the input least capacity int array. Just
And now Lawrence is up solving like now Lawrence is solving these. So I think Lawrence has pretty a really good lead now. And this seems like a DP problem.
so we're learning Kotlin as we go. So yeah, if you allocate, it's in that's most of the collection framework in Kotlin is inherited from Java. So you create array list and stuff by default they're empty, and the number it specifies not the size, their initial capacity.
Did Director make the same mistake? No, I because I think host like speak about it last time. So
Oh, something wrong.
wow, what did he miss?
Something is wrong here. And while Camille is debugging, let me let me explain you the next problem, the next that Andrew is solving. So in the next problem, you have a schedule. Yeah, that's kind of classic dynamic programming problem. So you get a day that's length as h hours in a day, and there is a schedule of sleep times where Wo goes to sleep. So he sleeps for some time and then goes to sleep, and it's all loops modulo h because h is the length of the day.
Yeah, that is also a thing. But but host is also giving them hints because I think host is more proficient in Kotlin than both of them. So I think he's kind of helping them as well. Kind of like it's a trade-off. He's also helping you, and he's also like a hindrance.
You have to optimize the choice here for you have.
So Errichto is still debugging his code. So like I used to watch Errichto a lot when I started CP. So I learned most of my tricks and tips from Errichto. Yeah. So I like owe him a lot.
Oh, great! That was fast. That was fast. That was fast. So
So you can see how good these guys are at DP. So Lawrence already solved D.
the next problem is
Because I think this problem was not that much of implementation. It was just about DP, so he was able to implement it much faster.
the last one.
Yeah, I have learned a lot of things from him. Like I do not follow guys like Striver and such guys because I don't believe in courses. I think courses are a waste of time. I think practice is the best thing that you guys can do. So like I give a lot of contests, and at that time Errichto was quite active in the community. So like I watched a lot of his streams and a lot of his videos. I learned how to implement binary search. Yeah, a lot of things. Yeah, second thread is also good. Yeah, but I think both of them are quite inactive now because I think second thread is busy with his job at Facebook, and Errichto I think is also having a full-time job now, so they are not able to stream that much. But still, I learned my debugging skills and everything from Camille, so I owe it to him.
Not knowing Kotlin standard library will harm them because it's actually you can do this check that Andrew's trying to like really with the one-liner in Kotlin, but you have to know its standard library. So to make this check, the Andrew will have.
Yeah, you can see Errichto. Yeah, where can I access the streams? Yeah, they are on YouTube as well. So I think there's a channel called Errichto 2. I think they will be on they will be on Twitch as well, but I think they are also on YouTube under Errichto 2. You should be able to see the streams from there.
I think we'll have to write some code. Well, we'll see. We'll see how he does it.
Also, he does a lot of ad coder hard problems, ad coder grand contest problems. I am not that good to absolve ad coder grand contest E problems, but yeah, like if you are into solving hard problems as well, you can watch his ad coder grand contest streams. They are also quite good, but they are only for like people who want to solve pretty hard problems because he struggles a lot in these problems. Not ARCC, AGC. ARCEs are not that hard. Like I can solve those problems, but ad coder grand contest E and F problems are really hard. Like I have seen Errichto struggling for like 2 and 3 hours and not being able to solve them. So you can see how brutal they are. Like they are like kind of hardest problems you can solve, but they are like really fun if you want to challenge yourself.
And Camille D
Camille is still debugging. Yeah,
the
he's
debugging
struggling a lot.
true pruning algorithm. Okay, okay.
Let's see.
It now and
Hello, bro. Yeah, Oscar.
I hope Camille is done with pruning, and
I will now switch to F instead of E.
okay, well, try. Yeah, there E and F. I mean, E is.
Oh, you got a wrong answer.
They
Nah.
don't have much code, both of them, but from number of points, yeah, it's
Yeah, so I think yeah he should move to F now because like the scorecard 100, 200, 300, 500, 600. So if we talk about Errichto and we have Lawrence. Errichto has solved I think these three, so he's at 600. Lawrence has solved these two, so he is at 900. So whoever solves problem F will win the game. So solving F is really important. So he should like move to F now. He should just leave D.
probably makes sense. Oh no.
Just
Even
leave D,
doesn't
bro.
work so
Like,
well.
don't try to do E now. Just move to F. It will be more. I
I know.
think it will make more sense because D is I think a lot of implementation, and it will be better if you just move to F.
No, there are some more special cases. Oh no, that's bad. Meanwhile, Andrew is still thinking. Well, let's see. So Andrew is thinking on the last problem, which is to maximize K, modular. Yeah, module special cases as usual.
Thanks.
Who is this guy? I think I have seen him somewhere. Oh, he's the guy who sets education around, like, right? What is his name? Blood Test, I think. He's Blood Test, I think. He sets like educational rounds for forces.
Yeah, in Kotlin you can do local functions, and
I
local
thought he
functions
was
are
like
actually really
he
helpful.
I've seen him somewhere.
I mean, they're helpful in industrial programming too, but they're really helpful in sports programming. The fact you can just write function locally and access all the other state you have.
So these are like the local functions in Kotlin. I think they are quite similar to Lambda function in C++, right? You can write Lambda function in C++ and access all the variables of the parent function. So I think yeah, these functions are really similar to Lambda functions in C++.
Helpful in sports programming. The fact you can just
Lawrence is gonna win this one because he has quite a
and,
lead on problem F.
access
So
all
yeah,
the
he's
other
gonna
state
win
you
this
have.
one because Errichto and Lawrence I think are quite on a similar level. So Lawrence has a lead in terms of time, so he's gonna win this one. And obviously Lawrence has better experience using Kotlin also. Errichto is still
Middle
stuck.
A. S. Okay, so Andrew will be checking his numbers modulo K, but he also need to figure out which modules to check. So because you can sum booleans, like you have a boolean expression for sum of. It's
Yeah, Saturday. Yeah. He's right on the edge, around 4.7 seconds.
Camille's catching up.
Also, Camille has been to IMO, so he's quite good at maths, so he should be able to do it quite fast.
That's a bad case of Kotlin. Just make something like this. No, actually, do one to int, one dot to int, and
You see, the host is helping them as well, right? You cannot blame the host. He's there to like bridge the gap between Guys, it is.
On the that will fix it. But ignore this thread. That's actually
So he's there to
sometimes gets
bridge the gap between
reason
us
for this
guys and
crazy thing is
contestants.
because literals in Kotlin they actually special case they exist as both as integers and long, and this plays trick with overloading when you
So Errichto has started to code F as well.
yeah.
This is a head-to-head now, yeah.
Mike, how much time do we have? 4 minutes. Yeah. So we do have chances for you to finish this one. Those differences, something like this. If it passes the test. Warming me up. Yeah! Congratulations to me. So let's.
So yeah, Lawrence won, like I said.
Warming me up. Yeah! Congratulations. So Camille has few minutes to finish the same one.
Like I said, yeah. So Lawrence has quite an advantage on hard problems, so he was able to win just because of that. If Errichto had better implementation skills, he would have won.
C. Thanks to the same.
Because I think problem D was not that hard, that Errichto will be stuck at it for so long. I think, yeah, he was just stuck because of some implementation issues. So like, yeah, well played by Lawrence as well. I think Lawrence would have gone for, no, it would have been draw, I think.
Problem.
Very clutch by Lawrence.
Same bug. I mean, that's amazing.
Yeah, so Lawrence won. So he had 1500 and he had 600.
Yep, another bug. I mean, half of them can be already the same.
Oh.
Yeah, submit. Submit.
I still have time.
You're running out of time.
This was fun, I think, yeah.
Okay, yeah.
20 seconds.
18 seconds, okay. Hopefully it's correct on the rest of this. Oh, yeah. Yeah! Congratulations!
Nice one, Errichto, yeah.
Congrats.
Yeah, this is a fun stream, yeah.
Thank you very much. I mean, Andrew, how was your experience?
It was good. I had some hiccups. It turns out I don't know how to solve easy problems.
Yeah. He struck a
But
lot
once
of
we
easy
got over
ones.
that, it was pretty smooth. How would you iterate over like all pairs in two elements in an array? I just didn't want to duplicate iterating over the same element twice. So I wanted to do for I in A, for j in A, but I didn't want to I wanted the divide by 2 factor.
I did it exactly the same way.
Yeah. It's called step. You do a range called space step 2.
No, sorry. Here I'm trying to iterate over I less than j in the array.
Yeah.
AI less than AJ.
Yeah.
But if I just did for I in A and for j in A,
Yes.
then it would take twice as many.
Yes, exactly.
It would take the 2x overhead.
Yeah. It will twice as many. So I mean, I usually write it like this too.
Okay.
I mean, I usually when I do sports programming, I usually also do manual loops, like specify from 1 to n and from I to n and stuff like this.
Okay. Yeah.
That got you on.
Indeed.
What's the last problem?
So I had a set with kind of hashes of degree, ID of a vertex, right? I don't know how to create a set of pairs. And sometimes I would first put negative numbers there, so degree of something became 0, or maybe even negative, and I still inserted it back to set. So set had some, let's say, zombie elements. Later, when I changed it, I did it in incorrect order, and if I remove multiple leaves at the same time, in particular if they touch each other, then like one of them change to minus infinity, but the other would affect the first one. So yeah, I just inserted and removed things incorrectly from the set.
I see. Yeah, so I mean that's probably Andrew got a little bit head up because he had a little bit more Kotlin experience. So he
Did you
knew more
use pairs?
things.
Did I what?
Did you use priority queue? What did you use?
No, I just use a queue. It's just BFS, right? And so
Yeah,
you
it's
don't need-
BFS, yeah.
Oh, I see. Yeah.
Yeah.
Yeah,
Yeah.
Makes sense.
Yeah.
he wrote simpler code actually with the
Yeah.
queue. Yeah.
Yeah.
So thank you all.
Yeah.
Thanks for participating. It was really fun watching. I mean, really nice coding, and you made it in time.
Yeah.
Thanks a lot.
Alumni talk very.
Yeah, so yeah, quite good. Do let me know if you guys have some other recommendations that I can react to, and I'll be more than happy to react to some other videos also. And that was it for this stream. Quite a nice stream, a good to react to, quite educative as well. So like you guys can share some videos that I can react to in my next stream. That will be quite good. Not right now, Rohan. Like maybe in next stream. I will have one more stream this weekend. I can review. I'm quite tired now. I have to grab my dinner as well. So I will review it in the next stream. And that was it. See you guys in the next one.